Can you see the first page?
Yes, we can.
Okay.
Assuming the VW Bug is the first page.
Yep, that's the one. When I go out with the more or less portable, that's the setup. So first of all, thank you very much for invite. I was surprised, pleasantly surprised about the opportunity to talk about my little experiment here. I've been a ham since 2017, so not so long ago, but I've been a shortwave listener for about 45 years now. I started collecting radios since I was in high school. And I came to Canada in 96, 25 years ago. And my QTH is on Bowen Island, as I said before. And beside restoring and maintaining antique radio equipment, I also hunt for DX. And I experiment with all sorts of antennas. The magnetic loop, it's one of these experiments that I will try to share with you guys. I hope, yeah. So first of all, why magnetic loop? I always been attracted by this antenna ever since I was a young kid and watch old World War II movies with all sorts of ships having all kind of aerials on board, and I was impressed by the round loop that was present on all the ships, and then I found out that those are RTFs antennas, and during the World War II on naval ships, they were called half duff, HF direction finder equipment. And I said, I start looking, researching, and the literature found on the internet, it's quite wealthy on all sorts of details about these. And I start thinking about building one, but one that will suit my needs. And number one was to have as many bands as possible into one unit, and be able to transmit 100 watts at least, and to be portable. So on this presentation, I will lay down a few elements of the whole project, like the scope, design, construction, performance, how I'm using it, and potential improvements. As I said before, it has to be small, because I would like to take this antenna with me, not necessarily on a backpack, but be able to put it in a trunk of a car and be able to transport it wherever I go. The fact that it's not suitable for backpack operation is because I'm using 100 watts, and batteries for 100 watts used to be very heavy. Now they are a bit less with the new lithium phosphate iron batteries, but still they are bulky and heavy, so it's not suitable for backpacking. Due to the solar cycle we are in to date, as you all know, bands activity, upper bands, it's quite poor, at least from my location. Anything above 15 meters, it's quite a challenge. So I said anything that will go between 80 and 20 meters will be a good match for me. Also, I want to have a remote controller for the variable capacitor, so I don't have to go and it's not that I'm lazy, but I prefer to be on my operation table and not do 30 feet distance every time I need to change the band. As you will see, it's very narrow, the bandwidth, and it will imply quite a workout from my part. And also there's another reason for a remote controller. It's very sensitive, and every time I touch it, even an insulated knob on a variable capacitor, it will interfere and add some capacity from my body, and I will have very difficult time to tune the antenna. And also, what it was a challenge, it was I wanted to homebrew almost everything. Just to build the loop itself, it's not a big deal. It's just a few copper pipe, but the remote control and the variable capacitor, it was a bit of a challenge because in order to have 100 watts capability and the bands from 80 to 20 involve quite a big chunk of capacitance. Just a few words about magnetic loops. I'm sure there is nothing new in what I'm going to say, but refreshing a bit for you who don't are very familiar with these antennas. Most antennas are compromises of three elements: size, efficiency, and bandwidth. And magloop is no difference. If you want to have a small and efficient, you have to give up for the bandwidth. So it has a very high Q, which equal small, extremely small bandwidth. The big loop is fed by a coupling loop, which is also made out of copper. And a variable capacitor, I'm using it to tune the loop to resonate. There is very high voltages across that cap. I didn't have an opportunity to measure, but from the calculator I'm used over the web from 66pacific.com, you can see in these numbers that the voltages are quite extreme. For 80 meters, the antenna efficiency, it's only 10%. That's an ideal case when there are no, in this calculation, there are no resistance loss taking into consideration. So this is more or less ideal. But look at the voltages across that capacitor, 8,000 volts, and also quite a high current. When I saw this results on a calculator, I said to myself, well, probably it's not worth building it because I have these comments here. The specified conductor length of 3.5 meters is not ideal. They recommend about 10.4 minimum for 80 meters. And not even for 40 meters. They recommend 5.2 meters. For 20 meter, 3.5 meter circumference, it's okay. It's within their limits. But despite all this, I said I'm gonna try it and see on a practical level how the theory will match. So yeah, just one more thing about the theory here. As you can see, the bandwidth on 20 meters, it's 11.5 kilohertz. And on 80, it's 0.4. And I have to admit, they are almost right. When I start constructing it, I start to think about what will be more suitable materials for doing it. I know copper, it's more or less the ideal element for electrical conductivity in terms of resistance loss and price. So I choose copper pipe. I could have chosen a Heliax coax. Probably would have been the same result, but I was a bit concerned about the rigidity of it. So I decided to go with the copper pipe, octagonal shape. So I have 8 elements of copper pipe, 1/2 inch in diameter. I have a 2-inch plastic pipe for a vertical column. I have a coax cable. Oh, sorry. The capacitor module, it's here, and also the controller unit and the medium-sized tripod to install it. The backbone of this whole project was the variable capacitor. Initially, I don't know if you noticed, but I said prototype Mark 3.1. That means this is the 3rd version of this antenna. The first one was the same diameter, but it was just one single copper loop. So it was not meant to be disassembled. And the first capacitor I made, it was all aluminum. And it was only for 20 meters. The second one, Mark II, I built the octagonal shape with 8 elements. And I had an old radio receiver, an old military radio receiver from World War II. And I found in it a very interesting capacitor that almost matched the range of capacitance necessary for having a 80 to 20 meter coverage. But I couldn't put more than 20 watts into it. So I took the decision to build my own capacitor in order to fit the bill for 100 watts and 20 to 80 meter. So I built it out of brass with brass shaft. A type of this capacitor is butterfly with the air dielectric. And the range is 30 to 850 picofarads. It has a ball bearing shaft, and it's attached to a DC motor with the reduction gear. And the reduction gear is with anti-backlash, so it won't feel any how should I say, imperfection in rotation.
Hysteresis.
Exactly, yeah. And one more thing is, in order to eliminate any brush contacts, I use this ribbon, brass ribbon. So the capacitor does not rotate 360 degrees, rotates only 180 degrees, which is absolutely sufficient for the task. Yeah, this is another view of the reduction gear. And this is the controller unit. which I built myself. You can see it's in very old style. I have a voltmeter, 12 volt voltmeter, and 2 push buttons for forward and reverse, and a rheostat for controlling the speed of the motor. That will enable me to have about 1 RPM. So very slow rotation. Sorry. Which is very important in order to be able to tune this antenna, especially on 20 meter, where it's very, you can pass the sweet spot very fast, very easy without noticing. So just to exemplify how slow the capacitor is turning. I don't know if the video starts. Can you see the video?
Yeah, that is slow.
Yeah. And with the help of push buttons, I can control it very precise.
Yeah. So you cut all those plates individually, Lucian?
Yes, I made them. I made a template and I cut them all in bulk, and finishing them all in bulk and like a package. And all the spacers were made on a lathe, about 200 spacers or more. And I bought the ball bearings, but other than that, everything was made in my shop.
Okay, very nice.
So in terms of, probably you will ask how well this antenna works. Well, if you compare it with a Yagi beam or something like that, it's a lousy performer. If you compare it with the wire, probably it's better. But I try to compare it with the theory. Based on the calculator, it shouldn't work on 80-40 at all. I mean, 10% is efficiency, that's pretty bad. But as you can see in this graph, this is the test I made with Whisper. And I made tests about within a week. I transmitted in the morning, around noon, and in the evening on all 4 bands. And I have these results. This is 100 watts on 20 meter, just one day, one transmission around noon. So I could easily reach Japan. Actually, with Japan, I can daily, I can have contacts. This is throughout the week, all the bands, all the powers from 1 watt to 100 watts. The green arrow, green curves are 20 meter contacts. The lime color are 30 meters. The yellow are 40, and the orange are 80 meters. So even on 80 meters, I got contacts on the other side of North America. And regularly, I have FT8 contacts with the East Coast with no problem.
So is it bidirectional?
It is, and I will show you a very interesting graph just after this one. Okay. This one it's the stated power in watts against distance. So you can see on 100 watts, of course, I have most stations and the longest DX contacts. But still on 1 watt, I got a contact at 4,000 kilometers, which was a pleasant surprise. This is the most interesting to me, and it's exactly an answer to your question. You see, most contacts, this is as from a bearing from the receiving point of view. So receiving compass bearing versus distance. I would say 85 to 90% of my contacts were towards northwest north as a bearing, and which is very true to reality, because as I said before, I have the big mountain on the east side of my property, and unless I have a very high angle of attack, nothing will go through. But on the other side is the Pacific Ocean, and all the contacts were made like that. And this is exactly according with the theory.
1 watt, you could have gone long path, and then it would have been 20,000 kilometers.
Pardon?
Right? On the 1 watt,
Yes.
you could have gone long path, and
Yeah,
would have gone, 20,000 kilometers. As
that's
opposed to
true.
4,
That's true.
you know?
Everything is possible.
Yeah.
Yeah, so that's the theory of a loop, of a magnetic loop antenna. You see, a loop, if it's with the flat side facing the oncoming radio wave, since the flow of electrons in the two vertical parts are equal in strength and opposite in direction, they cancel each other out. So this is when you obtain the well-known nulling phenomenon with this antenna. And when you turn 90 degrees, you have a loop facing the oncoming radio wave. The horizontal arms are struck simultaneously, and the electron streams set flowing in them cancel each other out. But a greater pressure exists in the vertical arm A than in vertical arm B. So for electrons, therefore, will flow through the loop from arm A to arm B, and that will increase the reception. So that graph before the theory proved the theory very well. That's my my surprise, and I was very pleased to see that. This is a frequency against distance. On 20 meters, you see almost the same amount of contacts on all the bands, just the distance different. The distance is on 80 meters, it's way lower, but there are so many factors to consider, so you cannot judge the antenna only on alone. I mean, depending on how the band conditions are at certain date, certain time of the year, certain time of the day, you know, all this. It's very, very relative. Yeah, this is an FT8 graph. Again, just one day, I think around noon. The loop, it's the worst thing with this antenna. That's the most annoying.
That's a nice icon.
Pardon?
A nice icon you got there.
Yeah, that's the only contemporary rig I have in my Radio Shack.
What is it, 7300 or 7610?
7300.
Yeah, nice radio.
Yeah, very, very pleased with it. Absolutely. The thing is that this antenna can be used with either vintage or modern rigs. So I use it very, very successfully with this guy here. ESO FT101.
I thought you were pointing to the R390.
No, no, this.
Yeah.
I can show you, I have a short video of how I'm tuning it. So you see here, this is the sweet spot. As I move the variable capacitor, this lighten area moves back and forth. I'll play the video now. And so there is a station on 3742. I tune it on 3735.
Bingo.
So that's the internal tuner of the ICOM. So you see here, SWR, it's 1-to-1. So it's not for contesting by all means. But if you want to have, I can have SWR 1-to-1 anywhere on 80-meter band throughout 20-meter, but I have to choose the frequency and stay there. If I want to move 10 or 15, 20 kilohertz further away, I have to retune it. That's the most annoying part. Other than that, works very well. And this is a typical SWR for all 4 bands. You can see how, oh, sorry. How narrow the bandwidth is with most of the bands, including the 20-meter, which is only 20 at the best. So this is 1.5 SWR.
So you use the variable capacitor in the antenna to kind of peak it up, and then you use the auto tuner in the 7300. Don't you want to keep the tuner off and just use the antenna?
I can do both.
Okay.
Yeah, I can do both. I don't need the internal antenna tuner on the ICOM.
Mm-hmm. Okay.
This is what I'm planning to do with it. If I increase the loop circumference to 4 meters, I can be in green zone for 30 meters as well. If I increase the copper pipe diameter to 1 inch or even higher, or replacing it with Heli-X. I have to find a way to adjust the coupling loop, this here, to slide up and down, because the SWR points different from band to band, and I figure out that if I move just about a few millimeters up and down, makes a tremendous difference.
Really? That little distance?
Yes, yes.
Wow.
And yeah,
That would be tough to motorize.
pardon?
That would be tough to motorize.
I don't have to motorize it because if I choose a band, for instance, I go on 80 meters, I will stay on that 80 meters for a while. I don't really need to move.
Yeah.
Uh,
Yeah, you're good for the whole band, right?
yeah, exactly. And this is the current cable I have for the remote controller. It's just a 2-wire. And I'm thinking to replace it with coax. Probably it will eliminate some interference that I get only sometime on when I rotate the variable capacitor, introduce some noise. Why it's happening only sometime, I cannot figure it out. But this is what's on a to-do list. And the waterproof bag. As it is, the plastic box on the capacitor, it's not waterproofing. And I'm thinking to do this, to do it waterproofing, because sometimes if I'm portable and rain comes out of the blue, I don't want it to rush putting the antenna somewhere secure. I want to leave it in the rain and not worry about that. So that's about it. Thank you for your patience. I hope I wasn't too bored.
No, that
You
was
recognize these
Right.
globe
Great.
motors, do you? You recognize these globe motors, do you, Lucian?
So if you have any questions, please.
How did you, so on the magnet, you said the voltage, you showed us the voltage was quite high. On yours, is that caused by the high capacitance in the capacitor? What's causing the high voltage?
I think it's the as you've seen on a website calculator, it's generated theoretically, and I believe it's because of it's induced currents. That's my.
Because it's physically small. Daryl, you have to understand, when you put 100 watts in this huge dipole on 80 meters,
Exactly.
you spread the energy out. You can do it on a wire. It's no big deal. What the issue is, the physics are that the confinement of that energy in that small of a space is the current goes way up.
Oh,
Yes.
the I, yeah, okay, so the I goes up, okay, yeah,
Because it's not spread out.
right, okay, that makes
It's
sense.
it's very low impedance and very high Q. So it's sitting there switching between voltage
Really
and
low
current,
impedance.
flip-flopping.
It's like almost like a short.
Okay, that makes sense, thanks.
By
And
the way,
I've
great
seen
job
that.
on your capacitor, by the way. That capacitor is beautiful.
Yeah.
But I'm kind of curious, have you not been able to find like a vacuum variable at the flea markets or anything like that? Was that ever a consideration in part of your design?
Yes, it was, but I wanted to build it myself.
Fair
I
enough.
wanted to build something myself, and I took the challenge, and I knew I wouldn't be able to build a vacuum capacitor. That was way out of my league.
There's a little
But
bit
I
of
said an
glass
air,
on it.
yeah, an air capacitor is doable. And I built before the aluminum one, which was a very small capacity for the first loop. And I used brushes for the contacts. And I could tell you about the high voltage. I saw sparks coming out of that thing.
Arky
Yeah.
Sparky.
How about the current? You feel, does the capacitor get warm? It's something like hundreds of amps at 100 watts going through there.
I did not notice any excessive heat, but what I noticed once, actually twice, I was tuning with the internal tuner, and for some reason I had my finger resting on the remote control aluminum box,
Oops.
and I think some current came back and it burned my finger.
Yeah. Mhm.
Yeah.
Yeah.
And it happened twice.
Mhm.
Yeah.
Don't leave your finger there, man.
Yeah.
Put a plastic box around it.
Yeah.
The
Lots of
first one is
feels.
supposed to teach you not to do it again.
Yeah. Question, on your capacitor, what spacing did you use between the plates to handle the voltage? How did you come up
Brass.
with that?
The whole thing is brass. So the
Yes.
spacers between the plates, it's brass.
What's the dimension?
I think they are about 12 millimeters, half an inch.
Half an inch, okay.
Yes.
What motor did you use to drive that thing? Was that one of these little globe motors?
No, it's a DC 12 volt DC motor with the reduction gear inside, and on top of that I use that big gear that is visible on the whole unit.
The globe motors, this part here is the motor, this part here is the reduction. They were used on aircraft for tuning.
It's
Yeah.
similar. Yeah, Frank, you got
things.
something that's very similar. It's the
Yeah.
difference of manufacturer, but
Yes. Yes.
those are good to find.
I got 5 of them.
Yeah, I've seen people on who build these antennas. They are using stepping motors,
Right.
with coupled with Arduino computer, and they are fine, probably better than mine. But the only thing that kept me away is that being a step motor, probably they are not fine enough for the tuning, depending on how fine the stepping are.
Yeah, I think the guy that wrote the article in QST, I believe he used some form of reduction so he could even increase, because of he was 1.8 degrees per step or something like that. And
Yeah.
he cut it down to like 3 to 1. I'd have to go back and read the article. What was
Yeah.
interesting in his design was he automated the process for being able to find the energy center. Basically, he had his own built-in feedback loop, so it would find it for him. He was
Yes.
very complicated. And it was like, wow, that's
Yes.
huge.
Yes.
But yours is very easy to set up, meaning it takes you about 5-10 minutes to set up, and you're on the air on 4 bands.
You mean to set up the antenna?
Yeah, how long?
Oh, 5 minutes, less than that.
Perfect.
It's very, very easy.
And you don't
Very
have
easy.
to string it up in trees and
No, just mounted on a tripod, and you are ready to go. That's one of the advantage.
simple.
Yes.
Hey, Lucian,
Yes.
I was planning to build a magnetic loop using this 2,500 picofarad that I bought at the flea market. But as you can see, they couldn't stand a very high voltage. I was wondering, have you heard of anyone operating it in a can of oil? Would that work?
You're still dealing with a dielectric problem. If you arc over between the plates, when you go that high voltage, that's the issue. So if the oil is a dielectric, better than air?
I don't think so.
I don't think so.
No.
Oh,
The reason why you would use oil, Andy, would be to cool it, but I don't think the capacitor actually dissipates any kind of a wattage of heat. If it is, it's very little. I can't imagine it's that resistive.
Wouldn't it ignite the oil, Joel?
Excuse
I
me.
guess
Would
it's
it ignite the oil?
This might work for QRP.
For QRP, it's perfect.
Yeah.
You
for
don't
sure.
have a problem with that.
So on receive, do you notice, so you pick up the antenna for SWR transmitting. So of course you hear more noise on receive. As you rotate the antenna, can you null stations?
Yes.
Or null
Yes.
noise? Okay, so
Yes.
you're, okay.
Yes.
Uh-huh.
Sometimes, depending on the noise, if it's a day, like I said before, like a power outage, I don't feel anything because there is no noise.
Right.
But if it's a normal day with lots of noise, I can find a sweet spot and I can null it.
Mm-hmm.
Yeah.
That's great. That's great. Yep.
I wonder if it would be,
question. Oh, go ahead.
thank you. This is Rich, W6APZ. I wonder if it would be practical to use a plastic bag over your capacitor to avoid having to waterproof it.
Oh, that would be a very easy solution. Probably I will do it on the field if I'm not prepared to do it, but I'm trying to do something better. I don't think it will interfere with it.
This is Dirk. Thanks for the presentation. I have a question regarding the polarization. Did you try having the antenna basically lie flat down? Because then it might be like a vertical then? It might be then vertically polarized.
I never tried. I know a fellow ham here in Vancouver has a similar magnetic loop. He lives in an apartment somewhere in a high rise, and he uses it horizontally, but he's way high in further from the ground. So probably at a high altitude, it's possible and with good results. But close to the ground, I don't think it's feasible.
Okay, yeah, that makes sense.
Yeah.
But then it would be omnidirectional, right? Because the null would be kind of to the bottom and the
Right.
Yeah.
But then you won't be able to null it when you want it.
Right.
Yeah.
Was your next upgrade a antenna rotor?
No, because once I found the null, pretty much it stays on that position. It doesn't move. I found also to be very sensitive to the when I try to adjust the SWR, it's very sensitive to the position as well. I found this hard way. I tried to at one point without realizing I oriented the antenna in a different position and I couldn't find a decent SWR. And I scratched my head and I said something is odd. And I rotated without thinking that this might be the cause. And all of a sudden SWR was there. Good. And then I connected the dots and I said, look, that's another factor. But this happens only at my house. All those tests that I made and I presented to you were made with the antenna inside my house, actually in my living room. I'm sure if it's outside, the results are much better. Unfortunately, 2020 was a bad year for me and I couldn't do too many portable outings, some family problems. But a year before, in 2019, I did several with this antenna, and the results are very encouraging. The only problem when I'm outside is the fact that when I'm looking at the spectrum on ICOM 7300, I cannot see the sweet spots. I cannot see the illumination because there is no noise. And it's a bit difficult to find exactly where it is. But once it's there, it's there.
But you can up the sensitivity of the waterfall. So if you click on the menu there on the there's this little one on the bottom.
Yeah.
And then I forgot the name of the button, but you can make it very sensitive so that it lights up the tiniest bit of noise.
I know. I tried to do this, increasing the RF gain and putting the preamp on, the preamp 1 and 2. And it's solved in a way the problem, but it just bring up the noise throughout the screen, and you cannot really make a difference. But the way I solve it is I engage the preamp on a second level, and then I reduce gradually the RF gain, and then I could see the spot.
Oh yeah, but it didn't mean the RF gain or the preamp. I would have to look it up again where it is, but it's on the touch screen.
Yeah.
That you basically manipulate not the RF gain, but the sensitivity of the waterfall of the scope. Yeah.
Yeah, I will try to do that.
Which is not the RF gain. Okay.
Any other questions? So roughly how many hours do you think you've spent on version 3? Forget 1 and 2, the experimental versions. Approximately how many hours do you think it took to build that? Roughly.
Well, probably 90% of the time I spent working on a capacitor.
Yeah.
That took me the whole time, and then the second largest amount of labor was on the controller. The antenna was just a piece of cake, no problem with that. I don't know. I think hard to say, because I didn't work 5 days a week, right. 8 hours a day. You know, I work when I had time, and but I probably put about 200 hours.
This sounds about right.
Yeah, it does. But I'll bet you could build another one quicker.
Yeah.
Yeah.
Consider making one even larger, you know, not necessarily as portable, but would you consider making one a larger diameter?
Yes, I'm thinking, and not octagonal in shape. I'm thinking to build a square one, because I from what I studied, there is absolutely no difference in shape. So a square or an ellipse or a circle doesn't really matter. It's the same thing. And making a square, it's way easier and probably cheaper. And I've seen there is a hammer in Australia, and he built, if you can imagine, a loop for 160 meters. And it's gigantic. But he swears for the results of that. I don't want to build for 160 meters, but also maybe you've seen it. There is the Cadillac of magnetic loops, commercially made. It's a guy in Italy, Gino.
Alex loops or the.
And it's about 3,000 euros to buy it. It has a hydraulic control for the capacitor, and the whole loop it moves like this.
Mm-hmm.
And it has the capacitor plates between the two arms of the loop, and modify the capacitance by moving like this, and the control it's by hydraulics. And also it has a controller that it has an automatic tuner. So you don't have to look on a spectrum scope to find the sweet spot. It designed and produced a software that is doing this automatically, and he can tune it in 2 seconds or something like this. He input the frequency 7,200 kilohertz, for instance, and the antenna goes to 7,200 kilohertz with SWR 1-to-1, and he go 1,500 watts into it.
Oof.
Yeah.
Oh man.
Yeah, yeah.
Lucian, what is in the gap between the plates? Those plates, is it just air?
It's air, yes, yes. And the capacitor it's really big, and the distance between it's at least like this. I mean, it's really, really impressive mechanical construction, and also the electronics involved there.
Ah,
But
Yeah,
the price, it's
hey, you get what you pay for. He was
yeah.
at the DX convention 3 years ago when I happened to see it there. So yeah, it's an impressive piece of hardware. Not what you
Also-
might call portable either.
No.
Yeah.
So if you did a square one, maybe a stupid question, do you still have the circle coupling loop?
That's a very good question. I've been thinking about that yesterday. I said, because if you have, apparently the closer the coupling loop is to the edge of the main loop, apparently it's improves the SWR. And also if you have, instead of having a small circle, it's better to have like an ellipse. So the top portion of the coupling loop is closer, as close as possible to the main loop. Now, regarding your question, if you have a square main loop, and if you make a coupling loop also as a square, then you will have a parallel line between two, and probably will be very efficient. But practice will tell. Well, I will try. I will try.
I'd be tempted to try a folded dipole
A folded dipole.
to be right in line with that coupling to see how good of the energy transfer is.
Yeah. Yeah.
Because then it's like an ellipse, but it's really
That's true. That's true.
So I know people have done modeling using numerical models that you can get, like EasyNet or other better versions of that for like VLF antennas. We've done some of that in my work. And they work pretty well, even though the antennas are electrically small. So VLF, you got 10,000 meter wavelengths, and you got something very small. So have you read about or done any modeling using any of the NEC?
No, but I'm curious into this, and I will try to install the EasyNet software and see what results I'm gonna have.
Mm-hmm. Yeah, that would be kind of fun. Also, you can experiment with things without having to build them if you trust the model. Yeah.
Yeah, but that was the whole idea. I see, based on the calculation, this antenna shouldn't work at all. At least on the bands that they said it shouldn't work. But still, I can. I mean, now I heard stories that look, you can make contact with the bulb instead of your antenna, which it's also true. But
yeah.
Every year they try.
Yeah. But it works very well with both anchors as well. I don't need a tuner. I just use a power meter, and the power meter tells me the SWR, and I tune the variable capacitor accordingly. And when I'm on a sweet spot, I just tune the transmitter as the book says, and I'm ready to go. And with the FT101, I can put 125 watts, and no sparks so far.
Plus.
Very good, very good, very interesting.
Very excellent presentation. Really, I learned a lot from it.
Thank you for your attention.
Yeah,
appreciate your time.
Yeah,
thank you.
Thanks very much, Andrew. Impressive effort.
Definitely a different topic than we've had, so it's good, and congratulations on building such a marvelous air gap capacitor. That's terrific. Very nice machining there.